Valine has 3 possible rotamers with 3 different configurations about the C-alpha CB bond, C-beta bond. So the first configuration has an energy of 0 kilojoules per mole, B has 3.655 kilojoules per mole, and C has 6.127 kilojoules per mole. So notice that the energies are given in joules per mole, so instead of using the Boltzmann constant, we will use R, the gas law constant, which is 8.314 joules per mole Kelvin to solve the rest of these problems. So the first problem it asks for, calculate the molar partition function Q for an equilibrium mixture of these conformers at 298 Kelvin. So to do that is, as usual, you calculate the partition function, which is equal to e to the negative 0 plus e to the negative, make sure it's all in joules, I'm not going to use kilojoules, joules per mole over RT instead of kBT, plus e to the negative 6127 joules per mole over RT. If we solve this, the partition function is the sum of all these energy levels, which is equal to 1.313. The next problem asks for to calculate the molar internal energy of an equilibrium mixture of the conformers at 298 Kelvin. So to figure out the internal energy is you have this equation here, and the internal energy is equal to 1 over the partition functions, which is 1.313, times the first energy, which we got 3655, it's already given, times e to the negative 3655 over RT, plus E2, which is 6127, it's all in joules, times e to the negative 6127 RT. And if you solve all of that, you should get U is equal to 1 over 1.313 times 3655, 0.2287, plus 6127 times 0.0843, and then the internal energy should equal 1030 joules per mole. To calculate the molar entropy, use this equation given in red, and to do that is the entropy is equal to S equals R, which is 8.314 joules per mole Kelvin. Always write out units to see them cancel, times the natural log of the partition function, which is 1.313, plus the other half of the equation, which is the internal energy, 1030, it's all in joules per mole, you can't have kilojoules here, over the temperature, which is at 298 K, which is the same as the previous problem. And then you should get the molar entropy to equal 5.72 joules per mole Kelvin.